There's a mug here. Oh. Yeah. I got it. Ready? Yeah, go ahead. Oh, this is 4 minutes. Oh, okay, cool. Yeah, yeah, yeah. Pradeep, you said?
Yeah, I'm Pradeep. Yeah.
Are you or?
No, I'm working for Warner. I'm actually working from Cognizant,
Okay.
but for Warner Brothers as a consultant.
Oh, nice. Oh, that's amazing.
Yeah.
Oh, so you know Subhash?
Yes.
All right.
We work almost in the same place.
Oh, nice. Yes. Yeah.
Do you have water or do you need water in between?
If possible. I think I'm out of order.
Okay. Yeah, we'll try to get some water.
Okay, thank you, man. I appreciate that. Sure. What was your name again, ma'am?
Hema.
Hema. Thank you. Oh yeah, please. Yeah, just put that there.
Good afternoon and welcome all. I'm pleased to introduce Sooraj Akkammadam from Core Digital Media. Sooraj is the ETL Architect at Core Digital Media. He will be presenting a talk titled Standing on Shoulders of Giants, Building Core Digital Media's Data Platform Using Big Data Technologies. Please join me in welcoming Sooraj.
Thank you, Emma. Good afternoon. I'm representing Core Digital Media, and our talk today is centered around a tech initiative that was launched earlier this year. Our talk will highlight a problem our marketing team was facing and how the data team used streaming frameworks to solve this problem. Let's just start quickly moving on to the agenda. I'll give a quick introduction to our company, Core Digital Media. I'll then move on to how data flows in our organization and how marketing uses it for optimization. We'll then transition to the problem our marketing team was facing, the approach that we took to solving this problem, and how we implemented it. We'll then share the results of our implementation and some of the lessons we learned in the process. And at that time, we'll open the talk to any Q&A and if you may have. So, welcome to Core Digital Media. If you've been on the internet long enough, there's a very good chance that you have seen our ads. We are a direct response marketing and agency platform. We operate 2 online portals, Lower My Bills and Class USA. Lower My Bills focuses on connecting consumers with mortgage providers, while Class USA focuses on connecting consumers with education providers. We are powered by our marketing team, who operate across Facebook, Google, Taboola, and other online media to find consumers who will benefit from our services. We continuously evaluate new creative messages and new iterations of presentations on our online portals to find the right mix that will resonate with our consumer. We use data, technology, and analytical insights on a day-to-day basis. I'll give a quick introduction as to how the business works. The core of our business can be visualized as that of a funnel. At the top of the funnel, we use different marketing channels to attract consumers on our online portals. Once they're there on the online portal, we engage with the consumer. We help them understand their needs and try to match them with clients who they'll most likely find success with. We then reach out to our clients and see how the consumer that we send, how are they performing, so that we can adjust our services accordingly. There are 4 big KPIs that govern this funnel. The volume and spend, which pretty much indicates the amount or the marketing capability our marketing team has to attract new consumers in a cost-effective manner. The conversion rate, how well our consumers are lining up and matching up with our clients. Sales and quality, the client capacity and the overall quality of our services. And lastly, monetization. How well are we doing as a business? I'll now give you a high-level overview as to how data flows in the organization. So we extract data from our web app databases, which gives us insights as to how our online portals are performing. And we're also pulling data from our marketing publishers, which gives us insights as to how the marketing performance looks like. We then cleanse, integrate, and enrich and load these data sources into our enterprise data warehouse using a variety of ETL routines. The users now have a comprehensive view of the business and visibility into those funnel KPIs. This now will kick off a marketing optimization cycle. The marketing team will now analyze campaign performances throughout the day. We have our data scientists continuously pulling data from the warehouse and trying to evaluate their machine learning models. We also have homegrown marketing applications which are fed with enriched data, which are also used by our marketing users to create and manage campaigns. All of these come together to provide our publishers the right recommendations to optimize campaigns, which then drives the business forward. At this point, it's pretty clear. Integration is pretty important for the business. And the faster we are able to refresh data, it gives our marketing teams multiple opportunities throughout the day to optimize. So why is optimizing so important? Because it plays a direct role in the bottom line of our business. So now that we have established that, the opposite is also true. The slower we, if your data refreshes are running behind, it reduces the number of times marketing can optimize, which then affects monetization. So now we know that. Let's go back to the data flow again. We felt there would be a direct impact to our marketing team's optimization efforts if we were to improve the marketing performance data loads. This talk is focused purely on this section. So at this point, I'd like to share what was the load methodology that we were following before all of this began. So it starts with us receiving some data. So we get a wide variety of data entry points. We pull data from our publishers' reporting APIs or periodic intervals during the day. Some of our partners email us files. We then download these files and load them as load them. We also have our internal users dropping data points. And lastly, we have some internal applications that also gives us these similar data points. But the idea here is that as soon as we receive a batch of files, we run some kind of staging operation. By that, we load all this data into the staging layer of your data warehouse into some kind of intermediate table. And as you do that, you run some ETL routines, which basically do business rule validations, which does any data validations, data conversions. You may be getting data in UTC timestamp. You want to convert that to PST. And you may also be doing some data deduplication. Now you have cleansed data in that intermediate table. Now as soon as you have that cleansed data, you run some kind of main table operations. This is where you load into your main reporting tables. All the lookup data goes to your dimension data. All your performance data loads into your fact tables. At this point, data is available for reporting. Now the users now will start building their insights on the data that was just loaded. This is when most of them will start running reports to analyze campaigns. The data scientists start running their machine learning algorithms, whatever. Now one thing that is important to note here is the time that it took when the files got dropped to the time when the main tables got loaded. This is what we call a load delay, or the time it took to load a set of data. There is a point in which that load delay will become an optimization delay. Is at that time, because at that point in time, you have a missed opportunity for making marketing optimizations. From a marketing perspective, they're completely blind, like they don't know what's going on with the campaign. Is it performing well or not? So now we'll talk about when that how does that load delay become an optimization delay. So you start receiving a batch of files, you start processing them, stage operations, table operations. But when that's happening, you receive a second batch. Right? This is pretty clear now. Like you cannot process batch 2 till batch 1 is complete. Right? Somewhat? Okay. This is because you're using some kind of a common staging table. That meant that and because it already has batch 1 data, that means you cannot release that table for batch 2. What if you use another staging table? That's fine. But if you are using like a loader utility, like if you're coming from a Teradata shop, like a multi-load or a fast load, it locks the bloody table. That meant that you are looking at some kind of a process dependency. You have to load staging table 1 first, then only you can load staging table 2. Either way, the end result is the same. Batch 1 has to be loaded first, then go to batch 2. Okay. Okay. So let's see what will happen if your business is growing. You're adding more publishers, a lot more data is coming in through, and what the scenario will look for real in production. So you got batch 1. Okay. So you start processing batch 1, and then batch 2 comes along. Now batch 2 is not going to be batch 2 will not start processing till batch 1 is complete. Okay. Now when batch 2 gets picked up, batch 3 comes along. Now batch 3 is waiting. Now similarly, when batch 3 starts, batch 4 comes along. Now batch 4 waits, and so on. At this point, you know that if any of your file drops or any of those batches overlap, you're looking at a protracted load delay, and that is purely intrinsic to the process. There could be some other external factors here. For example, your database is very overloaded, and a lot of the users but hitting the database at the same time. So your actual staging and table operations are taking forever to complete. So at this point, this is about this time where some of you might have experience where users come to you and ask you, hey, is everything okay with the data warehouse? The data in the publisher UI is not lining up with what I see in the reporting and all that, right? So, and if you are working on a support role, this is not your day at this point. Okay, so let's recap. We have a tightly coupled process. Staging and table operations are very tightly together. Why? Because we have that intermediate staging table. Okay, you have a blocking process in nature, in the sense that when you start processing batch 1, and if another file comes along, it won't get picked up till batch 1 is complete. We know there will be at this point, it's not a question of it's a question of if, or like when and how many and all those kind of things. So we knew this is not going to scale for our business, and we felt we could do a better job. We started taking a holistic approach and wanted to come up with an ideal solution, and we wanted to also think about how, in a certain degree, how could we future-proof the solution. So we came up with some kind of fundamental design guidelines. We needed to think of staging and table operations, whatever they may be. They have to be running truly independent of, completely decoupled. We needed a continuously running pipeline, as in processing a batch of files must not be negated by the processing of a previous set of files. We needed a common interface for all our publishers, so that this would serve as like a common framework for all our marketing performance loads. And lastly, you need some kind of file tracking, because now you have this continuously running pipeline. You needed to know, this file got picked up and where it is in the pipeline, so that if someone was to come and ask you what's going on, you can quickly refer back to this situation. So knowing with all these fundamental guidelines, we had to, let's see what our new load profile would look like. So you would receive a set of files. We would run staging operations for this file. Okay, this is this time where you do your positional validations, you remove duplicates in the data, you convert your data points from one point to the other, you do some validations, etc. for that file that got dropped. But at the same time, you're also loading data into your main reporting tables for a previous set of files. You could do this because we have decoupled staging and table operations. And from a user's perspective, they're continuously building on their insights. As soon as new data gets loaded, they're seeing this data automatically getting refreshed in the reports, dashboards, etc. All right, so now we have our new load methodology. We had to think about, okay, what would be the components that would form our new solution. So let's go back. We had to decouple staging and table operations. We needed to have a continuous running pipeline. All this meant that no more database intermediate tables anymore. This very much was inserting the fact that we are leaning towards a messaging layer. Okay, with that, we then decided, oh wow, we could actually send the data in the publisher files as messages. All right. Okay, so now we established we are needing a messaging layer. We took up some critical requirements around that. One, it had to be fault tolerant and resilient. So you're publishing data to this message broker, and all of it goes down. You should not bring down the actual publisher application. We needed to be pub sub based, and at the same time host data for a short period of time, so that if the downstream app or the subscriber was down, it didn't mean an automatic data loss. We also needed to be horizontally scalable. So if our business is to grow and we had to maintain the same overall SLA, we should be able to quickly add infrastructure and still maintain that. Kafka pretty much ticked all these boxes. We needed a partner interface. So we had to be able to handle onboarding quickly of new partners. If a publisher columns around, we should be able to support that within our support SLAs. We took a config-based approach and incorporated all this into our publisher application. Our publisher application itself is Python-based, and we leveraged Kafka Python, which is Apache's library for Kafka. Yeah. So, all right, now we have data coming in as messages. We have to get them to where they ultimately have to live, the database. The data has to be written almost immediately to the database. Okay, So that means we need to have some kind of a stream processing layer. We chose Spark structured streaming as our stream processing layer, primarily because it is fault tolerant, resilient, scalable, and more for also for the Spark ecosystem. We felt that by adding Spark to our tech stack, there would be an immediate play for our data science team who want to analyze these messages directly within their machine learning algorithms. Another reason why we chose was the data frame API and the Spark SQL meant an easier adoption by our development community. So one thing to note here, to actually write data into the database, we had to leverage the 4East writer interface to build a custom sink, which does the actual writing. This feature right now is available only in Java and Scala and not in Python. So our subscriber app was written in Scala. Lastly, we needed that tracking layer. So prior to publish, we would note down the file name that was, we would establish some kind of metadata around the file, pretty much, which was the file name, what is the original row count, and then as we were about to publish, we would inject the file name into the message. So then when that data would get loaded into the database, we are at a point to know which file got loaded, what percentage of the data got loaded by comparing to the original row count. And obviously, as soon as file got loaded, we would then trigger off reports. So now that we have our individual components, we have to see how they all come together and form part of our implementation. So this is our architecture. It starts with a very simple, straightforward file checker. Did we receive a file from a partner or not? If it didn't find any files, it doesn't do anything. But if it finds files, it kicks off the publisher application. The publisher app will basically look at the partner interface and preps the data by adding some partner metadata to the file. It'll then proceed to enrich, validate, and standardize the data, and publish them as JSON messages to Kafka. Now we have a Spark app that's pulling data, that's ingesting data from Kafka. It reads these JSON messages and infers them into a data frame. We then use that custom sink as a for each action on that data frame, which will do the actual writing to the database. The custom sink will have all the Teradata JDBC references and will handle all the actual loading operations. Now this whole thing is running continuously with the publisher component running independent of the subscriber component. And from once data gets loaded into the database, into the warehouse, we have this external application that's tracking, okay, which file got loaded, what is the stats. If a file didn't get completely loaded, we would send alerts around that. And then obviously if a file got loaded, we start triggering reports. At this point, I'll now share the results of our implementation.
I have a question. The ETL part, where are you doing the ETL part? Are you doing the beginning, so that before when you publish a JSON message, you already kind of done all the ETL business?
Yeah, I was actually going to share that some of the So yeah, good question. Thank you. So this is kind of the results. The blue line kind of indicates like how many files we process. We process on average anywhere between 150 to 200 files a day. The second line indicates how much our average load performance times has changed. So as you can see, we went from a process that was loading that took about 20 to 25 minutes to something anywhere between 2 to 3 minutes. Looking at these numbers, it gave us a lot of confidence. And what we started doing was we started pulling data a lot more often from our publisher APIs, which is what you see at the blue line on the far end right there. And we started processing way more files. And what we noticed was we still kept about load times didn't falter. It didn't go up. It kept about the same. This gave us a lot of I would say like it confirmed our implementation. It confirmed our this architecture is the right one for the business, and it has set up the business for the immediate future. Some other material impacts was that the number of support tickets that was associated with the marketing performance loads went down drastically after this new architecture went live. So this resulted in an increased productivity with our marketing and our data teams. And lastly, the original requirement was met, which was to give our marketing teams a lot more opportunities to optimize throughout the day. I will now share some of the lessons that we learned in this process. So we'll start with from a publisher ideology. So our publisher app, what we would try to do is we try to incorporate a standard message contract prior to publishing to Kafka. This is kind of done in part through the partner interface, but the idea here is that it helps in standardizing data elements across different publishers. For example, you have a publisher tracks website activity actions and another as conversions. This component would standardize them both as, say, applications. So this way you will eliminate any ambiguity with analyzing this message. We use JSON a lot. This helps in adding message headers, so that it doesn't. It helps like scale the publisher app. We don't have to make a whole scale changes to the publisher app at that point. Next thing is the ETL operations prior to publish. Sometimes you may not be able to. It may not be physically possible to do this, but if you can, you should try to do this. We take this time. We take this opportunity to validate, enrich, and data. And by doing this, we give a consistent picture of the data for any downstream app who are pulling data from this topic. And another thing that really benefited our use case was that it greatly simplified our subscriber app, because we could treat the subscriber at this point as a pure, simple ETL writer. Moving on to the subscriber component, we highly recommend you use prepared statements. So when you use a prepared statement, the application will send the SQL statements with variable parameters instead of the actual data. The database then based on the statement will analyze, come up with the right execution steps. And since you're using the same statement again, when the app now sends the data, the database won't recalculate the execution steps because it already has it in memory. Then based on your actual loading operation, things might change. So our straightforward update else insert. You had to update the target table with the latest data coming from the messages. For the record key does not exist, you have to insert it. So we combined update else insert into a single statement. This is a Teradata specific syntax. It may differ based on your database. But the idea here is that because we were able to do this, we could have one single writer that handled both update and insert operations, as opposed to having two writers, one with a dedicated update and one with a dedicated insert operation. The last thing would be based on your and your cluster. We used Yarn as our manager. So based on our SLAs, we had to come up with this ideal number of executors and task slots. So that's something that you'll have to play around with. We highly suggest also enabling back pressure for Kafka. So this helps setting the ingestion rate to be set dynamically and automatically. So you don't have to do a lot of legwork. So thank you all for coming in today. And at this point, I think I'd like to open up for any questions that any of you have. Please.
Are you hosting this all within your own data center, or are you using like AWS or Azure?
So right now we are doing this within our data center, and because this is such a production critical application, we did go with vendor support too. Please, sir.
So when Kafka like sending message or insert data, if like some data, bad data didn't get inserted, other than like getting error message like reported, can you go back to restream it or send it?
So that was one of the benefits of the file tracking layer. So we would track, like we had certain error thresholds that would track. So we know this file, what was the original row count, and then we expect 100% hit at the end. So based on that error threshold, we could track. And so when that alert happens, we had a whole support team at that point. We would then look at, okay, which file had a problematic issue, and then because we still have the file, this is not like an IoT type data where the data just gets vanished. We still have the file. We can actually open up the file and see what's going on, or run it through the publisher app and see what's going on at that point.
So we will manually restream it?
Yeah, we still would do that at that point. If it was such a, if we saw it greatly greatly go over that error threshold, totally.
How stable is your new application?
It's a very good point. We haven't had that many failures. I don't see a wood here, but okay. But so far, we kind of know most of our errors are kind of handled up prior to publish. So like if someone were to send a junk file, like you were saying, we had a partner interface that would actually validate this data as opposed to, so you know that we would actually check the metadata of this file to see if it conformed to a certain business rules, and that file, what we are, if it's supposed to process what we are supposed to expect. So based on that, I think it doesn't fail that often. Yeah. Just one more. Yeah.
Do you have experience with Apache Airflow or any workflow management software? Could that be a tool that in this situation?
So for orchestration, we were using our existing tool. So we still have a lot of like batch jobs in Informatica. So we incorporated all these stuff inside of it. The only thing was the publishing side, which lives in Informatica, but the actual Spark, everything is written on its own. But yeah, you could technically use Luigi or Airflow or any of that to establish orchestration. Yeah.
Did you say you use vendors? Because how did your team structure change based on now this new? Did you bring in vendors to do that, or did you retrain your team on how to now support?
So that was one of the really good side effects of this implementation, because now it gave the team a lot of opportunity to learn these new technologies and start picking up something new. And but yeah, most of it is done by ourselves, because if you think about it, right, most of it is not rocket science. This is straightforward ETL. I mean, it's just like, okay, it's just that the game changes, but the rules don't change. So I think we kind of like we figured it out as we went along, and that's why some of the lessons that we learned which were critical for us, what we are sharing with you today, like stuff like prepared statements. You will definitely see a big impact to your loading performance if you were to use something like that. Please.
What about if you have some complex transformation rules, or you reference some other tables to make some functions, something that is out of the ETL logic? Where does all that logic stay in that?
That's a very good question. So it really depends on the complexity, right? Like just like you said right now, our publisher, if you were to think like now, our publisher app is very, I think the word is a monolith-based application right now. As in, you have this big giant thing that's doing a lot of things, right? What we really would like to do, our next iterations around this would be to split this monolithic type application to a series of microservices, where data gets cascaded from topics, and as data is going, so as data gets cascaded across topics, is where you have all these components. It checks, okay, oh, I have to do this complex logic based on this type of data, and so we were thinking of doing in that side. Please.
I'm thinking about it, since you already have file tracking mechanism, you know which files to catch up, and you can pass them to JSON file. Why you still need Kafka in this case? Why just don't pass the JSON file, get the insert statement directly insert the database? Why you need Kafka in this case?
It's a very valid thing. We just felt like we wanted to kind of like future-proof it, set it up for, because what we do, one of the things here right now is it kind of gives, by working on all these different components, it gives us different ideas to think about. So for example, right now, I'm pretty sure in a year or two, we could be at a point where we could tell the publishers, hey, instead of sending us files, why don't you fire a message from your ad server that immediately talks up here? Why we are able to do that? Because we have a Kafka infrastructure, and we're at this point where we can start thinking all these different things.
So this is like a proof of concept that you're
in a way, but at the same time, it serves a very big production critical thing here. Please.
I think the other thing which you have to
That's true.
But if you have like a direct insert, you are like it's going to be locked the data. But this acts as a buffer. Okay.
Yes, sir.
You are file tracking. How you are making the file tracking? Are you using any visualization tools or
Yeah, actually, so we at the end of the day, all the file tracking goes into the warehouse, EDW. So you have so we plug and played our MicroStrategy onto it. So now users can go and see, okay, what's going on, which file got loaded, and all that. Please.
would you be able to describe about the process of migrating this SQL ETL to the message-based ETL?
So you really, that's a tough one, because now at this point you're starting to think about more, like from our perspective, say you have a file, you have to think about like you should not read all this file entirely in memory. So if you're in Python, instead of doing like Python file dot read lines, which is a really bad approach, you should do with open file, and then you should at this point your thought process starts to change, because SQL is actually a lot more simpler as opposed to doing this.
So when you're doing the SQL base, basically you have a stage area or stage tables that you load the data in, and you have multiple batch one after another.
Yeah.
And now when you migrate to this message-based ETL with Kafka and Spark, like did you develop the entire system and swap it out, or you basically migrate piece by piece?
Oh, no. Okay, I understand your question now. It was a hard migration. So we basically decommissioned the entire job the previous time around, and then we moved to this new setup. Yeah. So yeah, it was because we didn't want to have like half components there, and we felt that like kind of defeats the purpose. So we just took it was like think like yanking Band-Aid. So we just did it.
Was it feasible to do a more gentle migration as opposed to here's a hard cutoff?
So again, that would depend on your use case. So if you have like hundreds of jobs, I would highly recommend that you do it like piece by piece, and then possibly cut over like that. But if you had like about like less than I would say 15, 20, I think you could probably do it all the way. That's why the partner interface played a huge role, because you had this one common interface that talked to all the jobs. So that's why it kind of like helped us. Does that answer your question? Yeah, please.
In case the exact file processing is failed, how you handle it?
Okay.
Repeat the question.
So typically when you have a failure, we have PagerDuty alerts that comes out to us, and then we start looking at the problem. Would you mind clarifying, would that be on both the publisher side? I'll explain it both from the what it looks like from the publisher side and from the subscriber side. If a file did not publish and there was some huge error, it did not get caught, we'll have to like look at the failure, and then we start analyzing the problem. We kind of we log everything that's happening in the publisher app, so we can actually track and see what the problem is, which file got affected, and then we start fixing the file, or we reach out to users or maybe our partners who send this file. Now from a subscriber app, there's two main failures. Either Spark goes down completely. So if Spark and all that app goes down completely, we have a process alert that actually checks if that job is alive. If the job goes down, we have our ops teams who are like making sure, and we'll coordinate with them to get that app up and running. If it's the other case around, where the app is running fine but nothing got loaded in the database, our file tracking layer kicks in and then sends us alert saying that, hey, this file didn't get completely loaded. So then we start knowing, again, it goes back to the same use case where you look at the file, see what's going on, and then we do it. Anything else?
So in this process, your stage tables processing went completely away?
Well, it didn't go away.
Or
It's
you
part of
still using it?
our publisher app now. Yeah, so we do that as part of the
So the
publisher.
publisher's still using it, and then you're reading it out of the stage tables to put it into the web to go to the subscriber?
No, we don't use any more database instances. We just We do all our ETL operations inside the application, and then we push it in. Please.
So are you planning to replace all of your ETL jobs with this architecture?
Well, so let's go back to the data flow, right? So we've solved, I think, one half of the equation, which is to get our marketing performance data. So now we have our online portal data, which kind of tells the onlines how the websites are doing. How many sessions are we coming in? How many, which products are are tanking, or which products are doing really well? I think there is a plus factor there to get this data also in this kind of an architecture. There's a different kind of a challenge there. Because that's something that our web engineering teams are actually actively working on right now. They're moving into a microservice-based line. So now, as soon as activities or events happen on the web pages, they are also aiming to publish this data into Kafka. So we'll have this. So I think this would be like a springboard for that. Yes, sir. So that's kind of baked in. So remember the standard message contract. So if you had a publisher file that gave you only, say, a 2 or 3 out of the 2 of the 3 data points, and you're expecting normally 3 data points, our part, because we are using a standard message, we would then say like, okay, we got data from 1, 2, and then there's a 3. The third metric is pretty much empty. But at this point, the publisher knows to say, okay, hey, because you have to load only certain tables because of this partial data. So the writer downstream knows exactly. There is like a marker that tells what kind of a data is inside this message. So which table should come, which table should get loaded. Yeah. Okay. So I think I explained a different answer previous, but let me. So let's just assume you have a publisher file and the data there's like about 1,000 records, but for some reason you only got 500 records, right? So the process is straightforward. It's pretty restartable. So it's this update else insert. So you load the 500 row file, and then and obviously everything lines up fine because alerting does not get triggered. But then our users, our super users, they're like looking at the data. They're like, hey, I don't see data for this particular campaign. I'm pretty sure I launched this campaign yesterday. I should be seeing data here. So at that point, they have a marketing users kind of like reach out to their partners and go like, hey, can you see what's going on? And then they send us an updated file, and then we just process it through. Yes. But there's some time tracking or time tracking. Yeah, I mean it's pretty much straightforward. Like what you see is what you get philosophy at that point, because if you really don't know at that point, yeah. But yes, please.
Did you have to like change your hardware
Oh, hardware. So yeah, we got a beefier cluster because when we were doing our initial POC, and then, but yeah, so yeah, we had to do that a little bit based on that. Based on our requirements, we had to change that up a bit. Is that it, guys? Thank you.
Thank you very much.
Oh no, please, thank you.